So, up till now, we have learned three ways to solve systems of equations. The first way is you could draw the graphs. If you draw the graphs, then the solution to this will be where the graphs intersect. We learned that you could do substitution. If you could get an equation or a variable by itself, you could substitute it into the other equation and solve, and you would get that same point. Or you could use elimination. Can you see that this one works really nice for elimination? You could add these already up. If I add 2x plus x, I get 3x. Negative y plus y would be 0. Negative 2 plus negative 4 would be negative 6. And 0 plus 0 is 0. We could solve this. We would know that the x coordinate is 2. Then you could plug in your x coordinate as 2, and you could solve for y. Maybe some of you can do it in your head. You would get y equals 0. So whether we use the graphing technique, substitution, or elimination, we would solve that it intersects at 2, 0. And almost every question we've done so far has had a solution. But there are some systems that are different and have weird answers. Here's an example of two lines that are exactly the same. Same slope, same y-intercept. If you graph them, I could graph one in green and one in blue. They're exactly the same. If the solution is where they intersect, how many times do the same line intersect each other? Everywhere. Can you see that the green line and blue line, they have like, you can't just write one answer like, this would work, this would work, this would work, this would work, this, like, there's so many points that are the solution. In fact, the solution has an infinite amount of solutions. So we say that in a dependent system, that there are an infinite number of solutions. But we're going to discover today what happens. Graphically, if you tried to solve this graphically, you'd be like, I just drew the same line twice. If you drew the same line twice, infinite solutions. But what would happen if you tried substitution or elimination? If you try substitution or elimination, you will get a weird answer like 4 is equal to 4. And you're like, yes. Or 2 is equal to 2. Or 0 is equal to 0. If you get something that is always true, but all of your variables go away, that makes an infinite solution. That makes a dependent system. So in this one, watch what happens if I try to use substitution. Can you see that equation 1, it would be easy to get x by itself. X is equal to y plus 2. If I use substitution, and then in the second equation, where the x is, I write y plus 2, I end up getting 2y plus 4 minus 2y minus 4 equals 0. And, oh, these are like terms, and those are like terms. 0 is equal to 0. I was trying to solve for y, but my y's disappeared. But I got a statement. I hope you realize that 0 equals 0 is always true. There's never a situation that 0 doesn't equal 0. And so if you get a statement where your variables go away, but the statement ends up true, That only happens if your two lines were exactly the same to begin with. Sometimes you can write the exact same line, but have it look a little bit different, right? We learned you can write y equals mx plus b form or general form. They could be the same line, just in a different form. So we haven't seen a lot of these ones, because all of the questions we've dealt with so far have always been, find the one point that works. And that's usually the case. There is a third type of system where you have two lines that are parallel. If the solution is where the lines cross, where do two parallel lines cross? Never. And if they never cross, you'll never get a solution. So if you drew the graphs, perfect. You would see that they're parallel, they never cross. But what would happen if you tried substitution or elimination? I hope what's going to happen when you try either substitution or elimination with two lines that are parallel is you will get something that is never true. For example, in this one again, I can easily get x by itself to be y plus 2. And then when I substitute y plus 2 in for x, and I look at what happens, my y's go away. Can you see that the y's will cancel out, y minus y? And I get 4 is equal to 0. This is never true. If you think it's true, you give me $4, I give you 0 back, we're all good. So, because it's never true, this tells us that there is no solution. So now we have something that could happen while we're solving. Normally when you solve, you get a point. Most of the ones that we do are the ones where the two lines cross each other and get an independent system. But now there are some times where the lines are the same and sometimes where they're parallel. And you will either get an infinite amount of solutions if they're the same or no solutions if they're parallel. But we need to know, what does that look like while I'm solving? Because you might be like trying to solve this with substitution and be like, what just happened? 4 is equal to 0. Something went wrong. That could tell you maybe these are parallel lines. Would you agree parallel lines would have the same slope but would have a different y-intercept? So if I change, I'm going to call this green one equation 1, blue one equation 2. If I got the y by itself, can you see that equation 1 is x minus 2? Yeah. And can you see that equation 2, if I got the y by itself, would be x plus 2. They both have the same slope of 1, but they have a different y-intercept. So if you change things to y equals mx plus b and two things have the same slope, but different y-intercepts, that would mean that they're parallel and they will never intersect. If you change to y equals mx plus b and both equations are identical, well then you know that they're the same line and they have an infinite amount of solutions. So what we're doing today is practicing the techniques that we've had before, but we're trying to find out if we have an independent, dependent, or inconsistent system. And we will solve things either with substitution or the elimination technique. We won't do any graphing. What do you want to do for the first one? You want to eliminate? So, can you see that if you took, and I'll color code them again, I'll make this equation 1 and this equation 2. Can you see that if you multiplied, color coding, equation 2 and blue. If you took equation 1 and you multiplied everything by 2, then equation 1, if I multiplied everything by 2, would be 2x plus 2y equals -4. And equation 2 is minus 2x minus 2y equals +4. If I add things together, 2x minus 2x, 0. 2y minus 2y, 0. -4 plus 4, 0. Whoa. 0 is equal to 0. Is this independent, dependent, or inconsistent? This one is dependent. Infinite solutions they are the same line. The lines are identical. Yes. I didn't pick out the random number 2. Someone said, let's use elimination. And then if I wanted to eliminate the x, I need the numbers in front of the x to be the same, but one positive and one negative. So that's why I multiplied by 2 with the elimination. And it just so happened that the y's got eliminated as well. Normally in the elimination technique, one variable goes away and the other one stays, and that lets you solve. But this time, both variables went away, and we got an equation that's always true. That tells us that they were exactly the same line. Great, part B. Substitution this time because we used elimination last time, just to practice both. Again, I'm going to color code here. I'm going to call this equation 1 and this equation 2. And with equation 1, it's really easy to get the y by itself. Y is equal to -3x minus 1. So in the substitution technique, you look at both equations and decide which variable would be easiest to get by itself. And then I can take equation 2, and where the y is, instead of writing y, I can write -3x minus 1. What do I get? I'm going to get -6x plus 6x plus 2 equals 12. You see that your 6x's will go away. And you get 2 is equal to 12. No, not true. What does that mean? Inconsistent. This means that there is no solution. What's happening graphically is we have 2 parallel lines. 2 can never equal 12, so therefore these ones never work out, and we have 2 parallel lines with no solution. Yes? Yeah? So if I was using elimination, I would take equation 1 and multiply it by 2. If I did that, okay, can I erase? Has everybody written that down? So if we did this with elimination, I would take equation 1 and multiply it by 2, giving me 6x plus 2y equals negative 2. Second equation is negative 6x minus 2y equals 12. If I add those together, I would get 0 plus 0 equals 10. You get something else that doesn't work out. Also still not true. Also telling you that it's an incompatible system or inconsistent. And you would get no solution. Well, the one is 12 equals 2. If you subtracted 2 on both sides, you would get 10 equals 0. They're similar but different. Yes. Why did I multiply it by 2? Yes? Yeah, so if you're using the elimination technique, you want to have the numbers in front to be the same, one positive, one negative. So none of them are the same right now, so I chose to multiply equation 1 by 2 to make the x's the same, and by chance, the y's also eliminated.
So, do the y's have to be the same then?
No, usually you just make one variable the same, either the x or the y, to eliminate them, but then that lets you solve for the other variable. It's only in these systems that it goes away. Everybody good? Ready? So now, if I told you the one equation was negative 2x plus y equals 4, could you give another equation so that it creates an inconsistent system? In other words, what do we need here graphically? We need two parallel lines. This equation number 1, can you see that you could rearrange it to y equals mx plus b form? And if I rearranged it to y equals mx plus b form, I would know that the slope of my line is 2. So if I make another line parallel, it also needs a slope of 2. But if I need it to be an inconsistent system, it has to have a slope of 2, but not be the same line. How many choices do I have for my last number? Lots, right? Basically anything but 4 will work. Do you have a favorite number? Or a number you think hasn't been there for a while? Or you just feel like having some fun?
No, anything
No?
with 5. Oh, I already put it down.
Just 23? Or, okay, ooh, you like 5? Okay. Can be anything, right? Oh, we could even
No.
put a decimal inside of square root.
Oh, you're good.
It can be any number other than 4, right? I hope I did that long enough, because usually what happens is I say, is everybody ready at this point, and someone puts up their hand and said, how did you get 5? We didn't, like, it just has to be anything other than, you can ask a question. Oh, it can be any number other than 4. Independent. Independent, that's when you have your green line and your blue line need to cross somewhere. What is the only thing necessary for them to cross? Well, there's my green line, it's still 2x plus 4. What would make them cross? As long as their slopes are different, they would cross eventually. Does that make sense? So, as long as I change the slope, anything here, you could do 5, you could do 16, you could do 3, you could do -3, -5, -16, right? I drew a negative slope, so I'm going to put a negative there just because I drew it that way. I could have negative, and does it matter what the y-intercept is? No, could be. Any line with a different slope, no matter where you move it, will cross only at one point. The only way that they're parallel is if they have the same slope, and the only way if they're identical is if they're exactly the same. So I could put any number there.
Can they be the same, like, what?
Could be a +4. If they have a +4, you already know the solution. If they have the same y-intercept, that's where they cross. But in order to have an independent system, you just need lines with a different slope.